All right, folks, so this is the final question from, or part of question 1A from the November 2025 HL Paper 2 Time Zone 1 syllabus. As always, we're going to read it very carefully first, and keep in mind it's roughly 90 seconds per question, so that's about a 3-minute question right there. So here we go. Determine the frequency of electromagnetic radiation in seconds to the -1 or 1 over seconds, equivalent to the first ionization energy of phosphorus. Use sections 1, 2, and 9 of the data booklet. So when they tell you to use sections 1, 2, and 9 of the data booklet, they are giving you actionable information. They do not put irrelevant things in there. There are no red herrings. Section 1 has got equations in it. Section 2 has got the physical constants that you'll need. And section 9 are the first ionization energies. And so if you want to determine frequency, you've got basically two equations that have frequency in it, right? So even if you do not know what to do, just look at your data booklet. Look at the equations, that's part 1, and if you look all the way down this list, you will see that the only two things that have frequency are right there. That's it. So that means that one of those things has got to be what you want. Then take a look at what you're given. What are you given? Well, you are given the first ionization energy, right? That is 1012 kilojoules per mole. You are not given a wavelength of light. You are not given, well, you wouldn't have to be given C, that's the speed of light that's in the data booklet, but you are not given the wavelength of light. So that would imply that you do not need that, and that you must actually be using this one right here. All right. Well, if that's true, then you're rearranging this to solve for frequency. You're going to need an energy, which you can get from the ionization energy, and you're going to need H, which of course you know is Planck's constant, which is in the data booklet. So the first thing that we're going to need to do is we are going to need to get the energy. Now, the ionization energy in the data booklet is given in terms of per mole. But what we need is the energy to remove a single electron. So that means that we are going to have to take the ionization energy that we had, which was 1012 kilojoules per mole. Okay? Now, personally, I always prefer to work in scientific notation. That is 1.012 times 10 to the third kilojoules. But if I'm going to reduce that to the energy for a single electron, I'm going to want to take that kilojoules and I'm going to want to turn it into joules. Okay? So I'm going to multiply that by 1,000 joules per kilojoule. Those are going to cancel, of course, and I'm going to end up with 1.012 times 10 to the 6th joules per mole. All right, so that just kind of gets me going. That is the energy. So that is E. Now, I need that in terms of a single electron. So the ionization energy, and I'm just going to say for one electron, is going to be equal to 1.012 times 10 to the 6th kilojoules per mole. Well, how do I convert anything with moles to single particles? Well, I'm going to use Avogadro's number. Now, Avogadro's number is in the data book. It's in part 2. right here, the Avogadro's constant. Now, you should have this memorized by now, I'm sure, but just in case. So that is, excuse me, goodness gracious, let's try it again. 6.02 times 10 to the 23rd per mole. Let's put it that way. Moles to the negative 1. Oh, I did mess up, didn't I? I want to correct that. It's not kilojoules, it's joules. All right, so per mole, per mole. That is going to leave me with, and this is me running my trusty TI calculator before, 1.012 second EE to the 6 divided by 6.02 second EE to the 23rd is equal to 1.68 times 10 to the negative 18th joules, and I'm going to say per electron. All right, so that's what it's required to take one electron away. That is the E that we're looking for, okay? And the E is equal to HF. So if E is equal to HF, I want to solve for F. So what I'm going to do is I'm going to divide both sides by H, just in case you don't remember your algebra. And so that's going to be frequency is equal to E divided by H, which is Planck's constant. So I'm going to take my energy for the removal of a single electron times 10 to the negative 18th joules. Then I'm going to divide by 6.63 times 10 to the negative 34th joule seconds, which is Avogadro's, Planck's constant. Those will cancel out, and I'm going to end up with 1 over seconds, which is the unit for frequency. So 1.68 divided by, 1.68 e to the negative 18 divided by 6.63 e to the negative 34 equals, and I get 2.53 times 10 to the 15th waves per second, or second to the negative 1. So that is my final answer right there. And this one here was my answer sort of on the way. Now, a quick reminder about extended response questions in paper 2. If you write anything outside the box, it is not going to be seen, okay? So these things are all run through a scanner. The boxes are scanned, that's sent to the examiner. You could have the cure for cancer out here, no one would ever know. All right, so let's see how we did. The first mark is going to be the calculation of the energy, which is what we did first. So there we are. That's good. That's first mark. The second mark is going to be the calculation of the frequency, and that's what we did. That was the second mark. Full marks. Well done, us. All right, so that is all for that question. Please be sure to take a look at other exam questions and answers. In my reading of the subject reports, especially the paper 1B, requires quite a bit of work. People don't get a chance to work on them as much in class as perhaps they need to. Not the teacher's fault. There's just only limited time.